Welcome online people from the interwebs to Lunch and Learn, part 2 of DevOps with AWS. Last month was part 1 of DevOps with AWS, but we didn't quite get to the AWS part, so that's going to be Reese today. And with that, I will turn it over to Reese. Reese is an AWS certified, several certifications, AWS guru and software engineer, so he'll be presenting today.
Hopefully you can see my screen on the Teams meeting. All right, this is the intro to DevOps with AWS part 2. Like Joseph mentioned, we had so much content last time that we went over, decided to do the AWS part of it on the second half. So I'm going to recap that here in a sec. So we're going to do the brief review of the intro to DevOps that we did last time. And then we'll look at an AWS case study and some AWS tooling through the console, the Visual Studio extensions, and some other tools, and then kind of do some demos, and then have a summary. Feel free to ask questions. It's kind of informal, just whenever. We don't have to wait till the end. So if anybody has questions, just go ahead. So from the brief review of the intro to DevOps from last time, so it sort of started out in the 80s, the lean manufacturing movement. 84, the theory of constraints came out. Kind of going through this kind of fast because we talked about all this last time. If you missed it, yeah, just check out the last presentation. 2001, the Agile Manifesto came out, and people started doing agile development. 2009, there were some people at Flickr that started doing multiple deploys a day, and they called it Dev and Ops cooperation. And then 2010, there was an inaugural DevOps Days in Belgium, and this is where the term DevOps was coined originally, as far as we know, by Patrick DuBois. And then that leads us into 2013. The Phoenix Project was released, which is a great book that's sort of based in the same theme as the goal. It talks about software development processes and lean manufacturing as well. And then the DevOps Handbook, which is sort of like part 2 to the Phoenix Project, was released. The authors Gene Kim and some others. And then all that culminating in today's intro to DevOps Lunch and Learn, part 2. All right, so yeah, we're going to look at AWS case study and how Amazon transformed their culture and business. And basically created AWS internally first, and then realized that they could make money on it. And so in the early 2000s, Amazon.com was a retail website. It was a large sort of architectural monolith application. I think it was mainly focused on selling books originally, and then they started selling other things as well, as everyone knows. The organizational structure was hierarchical. Back in the early 2000s, that was sort of the style. You had these silos of development, testing, and operations teams, and they sort of threw stuff over the wall to each other. And then so Amazon saw this problem and decided to decouple their development process. They started moving towards what was then called a service-oriented architecture, or SOA, which eventually sort of became microservices in the more modern terms. So they also decided they needed to create smaller teams. They created these small cross-functional, what they call 2 pizza teams, which is basically a team that's small enough that 2 pizzas will feed. And so depending on how much you eat, you could have more or less, but it's about 6 to 8 people. And then their transformation didn't happen, overnight, but it's been going on for the last 23 years or so. And so, over time, they made these little small changes, and then eventually culminating into the DevOps culture that they have today. So then, talk about the monolithic software development cycle that they had. So they had, you can imagine, thousands of developers trying to integrate all this code into this giant website so that they could get it released. And they had problems like having to convince other people on their project that, hey, we need to add this new shared library, but maybe not everybody on the team wanted that, or it wasn't compatible with their functionality. And so it was just like this, you couldn't just like by yourself go off and deploy new stuff without having to realize how's that affect the rest of the team on this giant monolith here. And so any kind of fixes they needed had to be scheduled and make sure that other in-flight process changes or hot fixes or whatever they were working on were all sort of merged together. And that created this sort of like a merge Friday problem where everybody was trying to get all their code from the last sprint merged on Friday so that you could get it out to the website and deploy it over the weekend. And that sort of kept getting worse and turned into a merge week. And so they also had sort of this problem where they had all these manual touch points that led to frustrating developers and just slowing down the whole thing. And so they needed to make some changes. The first change that they made was architectural in nature. They started, like I mentioned earlier, they started looking at the SOA or service-oriented architecture. They decided to go jump both feet into it, and they reviewed their code and looked for sort of single purpose functions that they could wrap inside of web service interfaces. And then they made a rule that said that the functions can only talk to each other through the web service interfaces. So no more code sharing. It was totally separate. And they even went so far as to say no backend data could be access could be shared either. And so if you wanted to, if service 1 wanted to access service 2's data, it couldn't just hit the database and get it directly, even though that would have been easier in some cases, depending on the complexity of the service. But they decided just to stick with this rule, and so the services would have to communicate or coordinate with each other to be able to surface the data. And so this resulted in a highly decoupled architecture where all the services were independent. They could iterate on them independently. The teams were able to start cranking out code really quickly and make lots of changes. And then the company realized they needed to make even more changes to keep going with this. They needed to change the organizational side because they were having problems in the business. They had this one central hierarchical development team, but then they broke it down into the 2 pizza teams, and these teams had sort of full ownership. So you can imagine a team of 6 to 8 people, and in my head, I guess it's not just like a bunch of people that are developers. Like you'd have people that somebody was a developer, somebody's maybe more operations focused, somebody's maybe more development or database focused, somebody's maybe more project oriented, or like managing the life cycle of all the work items and project management. And so even though they had sort of this whole team of not necessarily specialists but more generalized people, they together, there's like the sum is greater than, or the whole is greater than the sum of its parts kind of concept. And they all had full accountability, like full ownership, everything from talking to the customers and figuring out what the requirements are to deploying it into production, as well as servicing it, even if it meant like fixing bugs in the middle of the night, whatever it took. That team sort of owned that service or services that they were working on. And this aligned the incentives across the teams, and they started to become what's now called a DevOps organization. Excuse me. Along the way during the transformation, they started to realize that they were missing some tools. When the new teams, they were starting to crank out code really quickly. When they went to deploy, they started to run into problems. This old model where they had a single, central engineering group was now this huge bottleneck because they had all these different teams trying to get n number of things deployed. And so what they decided to do was to create a new tools group that could focus solely on these problems the developers were having and start developing tools. So sort of tools like self-service things. So I could, instead of having to go ask somebody in operations, hey, I need a new VM for my web server, I could just go to a website and then have it create the VM for me in the background, and I could specify what I wanted to do with it. And then these tools had to be technology agnostic because the teams were empowered to use whatever tools and languages and things they needed based on what made sense for the problem they were solving, also what the team members skill sets were. And so they decided to and not have to, so that everybody didn't have to understand like what are all the best settings for a VM, like should it be publicly accessible and all this kind of stuff, what kind of security settings should they be. They just decided that this team had all that knowledge, so they should just bake in all those best practices into the services from the beginning, so that they could be single purpose. And so all these changes resulted in today, Amazon's able to do over 100 million, 150 million deployments a year. You can imagine these aren't large, big bang changes. These are, little hot fixes, small tweaks. Maybe it's even something as simple as changing a label on a text field, and the developer makes the change, and it goes through the automation. It gets checked in, it goes through CI, runs through the test, gets deployed, and then with using continuous deployment, not having anybody like a human really having to stop it at any point. And that's how they were able to get to that many deployments, I guess. And so, sort of the summary, I guess, that they, as far as summarizing the general design principles they came up with throughout that was, a lot of these things, sort of you can't necessarily do without having the cloud behind it. The cloud really allows them to do things like, stop guessing your capacity needs, right? Well, typically when you're not using the cloud, you'll go off and buy more hardware than you need, so that, if something goes wrong or you need a new server, you don't have to wait for, however many weeks for the new hardware to arrive and to go through the whole, process of provisioning it and all this kind of stuff. And so the other thing they started to look at was, you want to test your systems at production scale. Well, that's another thing that's kind of hard to do unless you buy redundant hardware. With the cloud, it's super easy because you can spin up an environment, do your tests, and just have it go away, and only pay as for what you use, kind of a concept, which is what the clouds all kind of offer, I suppose. And then you want to automate stuff with architectural experimentation in mind. So the idea that you don't have to get it right the first time. You just let's try this, let's try that, and with the flexibility and elasticity of the cloud, you can just try these experiments and not have the business feel like they're wasting a ton of money, buying a bunch of stuff that you're only going to use maybe for a little bit, only to find out that experiment didn't work or that kind of thing. And to consider that your architecture is going to be evolutionary, right? It's going to start off. It's not going to start off with the cloud. It's going to start off with one computer with one thing installed on it, and then you slowly build it up, and it evolves, as your problem set and your user base changes and all that kind of thing. And then you want to drive your architecture using data, not necessarily like gut feeling. I think we need this, or I think we need that, but the data is showing us, yeah, we need a new server, or this website has a problem in the middle of the night every once in a while, or whatever it is. Just like using the data to help you find the areas that you need to focus on and fix, and then improve through this concept called game days. And that I'm going to just kind of show up their link to that instead of trying to describe it myself. But whoops. But yeah, it's basically oh, it's not on the right screen. Sorry. I'm not sure why I won't go to the other screen. So you can't see? You can't see.
Are you sharing just the PowerPoint window?
Oh, maybe. Sorry. Let's see. Oh, here we go. Yeah, that's better. Sorry. Thanks. Yeah, so Amazon calls these game days. Basically, it's like sort of like an event where you simulate failures and other things that might go wrong with your system. And you actually want all the people to be involved, right? So it's like the business people, operations, the leaders, security, all the different teams, and so that you can actually find out like what's going to happen when something bad goes wrong with your system, and be ready for it and prepared for it. And with the cloud, you know, it's just that much easier. Without the cloud, that kind of a scenario is going to be quite a bit harder. Okay. And then,
You're sharing the.
oh, the wrong one. Don't know why I won't share that. Sorry about the sharing problem here. So hopefully you can see that.
Looks good.
Oh, I'm back to this. Sorry. It reset my slides. Okay. 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 Sorry about that. I need to work on my sharing. So yeah, I just wanted to show like a sort of a typical, here's a typical CI/CD pipeline. This technology agnostic, meaning there's no like technologies involved here or languages or anything. And I want to show just like the basic one, because I'm going to then show how the AWS services and tooling fit into this, and then do it. We're going to do some looking at the console, AWS console, and some other tooling. But yeah, basically this is sort of the typical pipeline. You know, you do code, build, test, release, deploy, and monitor, and then the various levels of automation, right? So you got continuous integration that gets you to the build and the test side of it, and then a deployable release that you then have to release. And the two sort of bottom sections are continuous delivery, usually has approval gates, and that's what the little stop part is with the screen there, where, you know, somebody in production might, or somebody from the business might need to look at it before it actually goes to production, versus the continuous deployment is fully automated and runs the tests and everything and gets deployed out there that way. So then, using that sort of same concept, this is the tooling that are the AWS Developer Tools that are available for you to be able to not only create the full pipeline as well as do all the things. So you can it'll create Git repositories. You can do automated builds. You can integrate with other tools like Jenkins or things if you wanted. You can integrate with GitHub for the code side of it. It has automated deployments they call code build. So it's sort of like the word code and then the stage that you're doing is how they named them. And then like for the monitoring, you can use the X-Ray, AWS X-Ray, which is sort of like a full end-to-end tracing service, so that you can get like from the client all the way to the back end and be able to figure out what's going on all the way in between. And that integrates with the CloudWatch. And so you can set up events and alarms and notifications and things like that. And so this is number 7 sort of shows this sort of whole section is called a pipeline, and they have a service for that kind of integrates all these things. And then on the very far left, they also have the AWS Cloud9, which is their sort of in-browser IDE. And so you can literally use all their services to do the development, everything you need without having to install anything, basically from your browser. You can use Visual Studio as well, and there's some tools I was going to show at the end if we have time. Looks like we will. So, and then yeah, also there's the Cloud Development Kit, which you can use to integrate things with your whole pipeline. And it also allows you to do things like you can actually write C# code that provisions resources, kind of like Terraform, except the output would be a CloudFormation template, which is kind of like Amazon's version of Terraform. So you can actually code, if you didn't know Terraform or CloudFormation templates, you can code it in your favorite language like C# or Python and be able to provision resources automatically. Mainly Python. So, but two things that I got the screenshot from Amazon, but two things that they sort of didn't have that are newer is this one called CodeStar, and then the Code Guru. And I don't know how well this is going to work with the sharing part of it, but I'm going to try to open it again. It might be faster to find it.
It might be opening, but because you're full screen, the window isn't showing.
Oh, yeah. Can you see that screen too? Or?
I can see your browser.
So that worked then? Okay.
Yes, yeah.
Yeah, okay. Okay, yeah, so CodeStar, I just wanted to kind of, so I don't have to describe it, they do a lot better job than I could. But basically, you can sort of spin up a full pipeline, like a CI/CD pipeline, within minutes. And I didn't really believe it, so I had, because it's, you know, it talks about start developing in minutes for you to be able to do that. So I did it, and I also, I thought they had a diagram. Yeah, I'll just leave it on this benefits here. I thought they had a diagram that showed how it works, but I'm going to demo it in a few minutes. But anyways, it only took about 10 minutes, and it spun up the whole, you know, created a repo. It added a sample app to it. It did a deployment, and yeah, and actually, I ran tests too, and it was pretty nice because it was like I went from 0 to having an app that I could start with. The app was sort of old because you'll see in a sec, it's an older .NET, like .NET Core 3.1. So some of their templates are a little outdated, but there is ways to create newer stuff too, I found. So, so that's sort of what the CodeStar is. And then, and the other one that wasn't mentioned that's on here was, or that was on that slide I showed you, was the Code Guru. And this is another tool you can integrate with your CI/CD pipelines. And this one actually allows you to detect security vulnerabilities, and it uses ML and automated reasoning. And I'm not sure what the difference between those are, but this one has a diagram. So yeah, you can basically see there that you can write your code, it scans it, and then finds issues and then enforces the security text before it actually gets deployed. So you can have it set up to where it doesn't even deploy it, it just sort of fails the test. I thought it was kind of nice. Okay. Okay. So some of the other automated tooling and automation and tooling stuff that you can do, I'm not necessarily going to go through all these. I was just going to kind of show off some of the stuff because I was going to also go and show off some stuff, basically the developer tools in the console. But yeah, starting with the top one, so the Elastic Beanstalk is basically creates full-on environments. It'll allow you to create a whole web application with spinning up EC2 instances, and which are like VMs, and just about the whole environment that you need. And then there's a .NET on AWS, so they have a full section for .NET developers. You can go and find information about how to build, deploy .NET applications. I thought that was kind of relevant since we're more Microsoft focused here at Intelitech than AWS. And then the toolkit for Visual Studio, I was going to show that. I installed it and set it up It's pretty easy to use. If you've got the AWS CLI installed, it just takes your profile and picks it up. And so it's pretty easy for me to then, after I created with that CodeStar, created the whole pipeline, I was able to just use Visual Studio, clone the repo, and be off and running. And then so they have another thing called the EC2 image builder, which is sort of a way, and this is probably for people that are not doing serverless development, but to basically create out your own virtual machines. So Amazon calls them AMIs, which is an Amazon machine image, but it basically you create like one example would be a golden image for developers, right? You want all your developers to have the same tools and not have to install them and configure them and all that. So you can build all that into an EC2 image, which is a VM, and then use that to then provision your developers' workstations and other types of servers, you know, if you wanted. And then the Proton service is a service that you can also integrate from AWS that allows you to gives your developers sort of the self-service capabilities. So one of the things that I sort of realized that Amazon did with AWS is they had all these tools internally, and then they realized, and then they were building out data centers, and they realized they had extra compute in their cloud, and you know there's all this waste basically, and so they realized that they could make money on that by selling off their services and providing that to other developers so that other people could benefit as well. And so that's basically what AWS is. And anyways, so yeah, so these tools were some of the kinds of things that you would do if you didn't have AWS. You could use these kind of tools like in-house if you wanted. But also they have other ones like, so I thought this one was interesting because like usually when you want to access the cloud, you have to install, you know, like their CLI, like Azure has one too, I think, and probably Google. Well, Amazon actually made a cloud version of it. And so you can just go with a browser, you can just log into the Cloud Shell and not have to install anything and be able to access your resources or do whatever you need to do, you know, command line type stuff from a browser. And it spins up a Linux terminal in the background for you. And so you're able to actually run, like, you know, real commands and things. And I can look at, we can open that too later once I get to the console part of it, if you guys wanted to see that. And then they have the Cloud Development Kit, which is the framework for defining this infrastructure and code and provisioning it through the CloudFormation. That was the tool I was talking about, where if you didn't know Terraform or CloudFormation tooling, then you know you can use C# or Python or whatever to define all your resources, and then it'll create the CloudFormation stack for you in the background. Okay. So enough of the talking part, and I was going to go through and go through the developer tools in the console, and then look at the CodeStar part of it, and then the toolkit for Visual Studio. And we got about a half hour, so I should have time to get through all that. If anybody has questions, feel free to just ask while we're going through it. I don't think I'm sharing my screen. Am I still? Yeah.
Sharing the PowerPoint stuff.
Just reshare this. Okay.
You can see it now.
You can see it. Okay. So yeah, so this basically when you go to the Amazon console, the developer tools is a section here where it sort of has all the, you can go to each one of these services individually, but this, I went here on purpose because it has like a place where you can see the full, if you imagine that CI/CD pipeline I showed earlier, where it had, you know, code commit and the build and then deploy in the pipeline. So these are all the different services. They also have an artifact one for your storing your artifacts if you had bunch of artifacts and things to store for like assets or whatever. I guess I'll just kind of go through these sort of high levelly, and then we'll talk about the CodeStar thing, which I used to create this whole pipeline in like 10 minutes or whatever it was. And then I'll show some stuff in Visual Studio. So yeah, actually, it might be better to show CodeStar first because that's sort of the package thing. So let me go there. Yeah, so I mean, literally, when you come in here, you just create the project. I can show you a couple things real quick. One of the things it does when you first come in is allows you to go through their templates, and you can filter this down a few different ways. So they have sort of three styles, I guess you could call them, to deploy with. The Beanstalk, which is what I was talking about earlier, where you can spin up a full web development environment. And EC2 is just a sort of a VM, and then Lambda functions are just a function that runs. It's just code that runs. And then, anyways, you can also, filter by the different types of applications that you would use. You can even make Alexa skills, I guess, which I didn't know you could do. And then you can select the different programming languages. One of the things I noticed right away, though, and this is what I was mentioning earlier with the .NET Core stuff, .NET Core 3.1, is these templates they have are pretty old. This is like, the one I used was this web application one. And you'll see the application here in a little bit when we get to Visual Studio. But I guess what I was trying to say there is it gives you a template and it gives you an application that gets deployed into your pipeline. And so it's just sort of a quick way to have something. I don't know that if I was doing .NET development a lot, I would use this for at least the C# ones that they had, at least this style of it. There's other ways to create the same sort of thing that I ended up creating through CodeStar, but use newer technologies. Because if you're using, unless it was an existing application, you probably wouldn't use .NET Core 3.1. And so what I was thinking that I'll show in a little bit is you can use that if maybe you were migrating to the cloud, because it's closer as far as like it creates an EC2 image where it installs the web server on that, and you develop against the web server, which is more kind of a traditional style. And so I'm thinking that's why they have that template still in here, even though it's kind of outdated. But they do have some newer stuff that I'll show in a little bit when you get into Visual Studio, where you can create new things. But the templates in Visual Studio seem to be a little bit newer. And then, so let me just kind of show you what I went through here. So I'm not actually going to recreate the whole thing. There's a couple more options. So then when you get in here, you can put a name in there, in the ID and stuff. And then this part of it was a little more interesting. So you could either use code commit, the repo, or you can actually integrate it with GitHub, which I thought was cool. And then as far as the web development part of it, when it's going to create an EC2 instance, here's where you can kind of specify some real basic information, like what kind, and then what VPC and subnet you're going to use. Of course, you can configure all that later too, but that would get you started. Okay, so after it gets created, I just called it Hello DevOps. There's sort of these next steps you can take. You can set it up with Cloud9 if you wanted. I haven't done that, but it's basically, like it says, a cloud-based IDE. It's pretty similar to Visual Studio Code, I would say, as far as the experience, from what I could tell. And you can add a bunch. You can set up the team members. You can set up other IDEs. You can even set up issue tracking. But it's only for Jira. So, and you also have to have an Atlassian account already. So, So if you wanted to integrate with like other types, then you have to do that yourself probably, it looks like. But then as far as setting up the different IDEs, these are sort of the tools that they support, I guess, out of the box. You can do it from the CLI, which you probably wouldn't if you're doing a web app, but they have Eclipse for like Java stuff, and then Visual Studio. So those are kind of the main ones that you would use. You can also use VS Code to connect to stuff and just, start editing it, just like you normally would with Git, just cloning the repo and that kind of thing. And then running the stuff, locally on your own machine. So I was going to walk through kind of what happened when I originally installed it. So when I first, and I kind of did some playing around with trying to get the .NET Core app to work or to be upgraded to .NET 5 or 6. But I ran into problems, and I thought I'd use that to kind of talk about some of the Visual Studio stuff here in a few. But anyways, so sort of the steps that it goes through are listed here. It gets the source code from AWS code commit, and then it does a build. Same kind of stuff you'd probably see in other pipelines, but they sort of have like this way to easily look at it, and then you can go and look at the details if it succeeded or whatever, and then troubleshoot it and that kind of thing. And then the deployment is using CloudFormation. And so they generated a chain set, executed it, and then using code deployed it, and deployed it, meaning it got deployed to the EC2 instance. And actually show what the app looked like. I don't know if I started it. So. I'll start it up just to show a comparison later. Okay. Yeah, just if anybody has any questions, go ahead and ask whatever. Okay, so these are the different services. I think I'll just drop into Visual Studio now, and we can look at it from that side of it. And then I'll come back to this here in a sec. Oh, this one. Okay. So for visuals from the Visual Studio side, one of the things you can install is this extension for the AWS toolkit. So I went ahead and did that, and that gives you some extra things that make it easier to develop and debug. One of the things it gives you is, or I have it over here, is the AWS Explorer. So here it, as like I mentioned earlier, it uses your, if you have the CLI installed, it just uses your default profile. You can change that, and then kind of gives you a view of the resources they support. They don't support all the resources for development from here, but you have the main ones. And in here you can, for example, look at the CloudFormation stack set that it created. it created a couple, one for the infrastructure and then one for the sort of the code side of it. And it's not too exciting. It's just sort of right now. I just have like what I had done last night as far as creating it and the whole pipeline and everything. So from here though, you can delete it and you can manage the resource that way. And then, so one of the things that I discovered when I was after I got this application and checked out the code and everything was, like I mentioned, it was using an older version, .NET Core 3.1, which I don't even think I have installed. But I must have something in here because it builds. But anyways, and so I tried to update that and I ran into problems. One of the problems I ran into was basically that you have to go in and change so they have this like build specification file, YAML file, and it kind of defines, it's kind of like Docker, I guess, but basically it defines your build, and you can change it to version 6, but I wasn't able to get the EC2 instance that it creates to have that installed already. So the other thing I found was they have an application spec, which sort of lists out the different parts of your app. And it was installed in .NET Core through this script. Which is under scripts. And then, so I found that you can run a yum command for .NET SDK 6.0, and I changed that to 6.0, but it still was like, it was like the EC2 instance that they were installing didn't have it, or there was some kind of a syncing problem or something, but it basically told me that it couldn't find the .NET SDK 6.0. So there must be more to it than just editing these two files. So basically, the interesting thing was I'm trying to basically author this web server, and the problems I was having is because the tooling was sort of old and outdated. And so while the rest of the team's out trying to figure out how to get the stuff upgraded, the developers decided they found that they could just go ahead and not have to wait for that, because we found that this application is just so old and we want to update it. So one of the things that you can do is you can add new projects, right? So if I can find the admin. So they have some new templates that come with that toolkit. And there are a bunch of different ones for Lambda projects, and you can use C# or F#. And some of them have tests, some of them don't. I didn't do a ton of experimentation on these, but it looks like you can create CloudFormation project as well. The interesting one though I found was the serverless application side of it. And so we're going to go, what the team found is that we don't need servers anymore. And so why are we trying to fix the build? And so of these servers, right? So the developers decided just to keep on moving, and they're going to create a serverless application. And what happens is when you select that, it comes up with these blueprints, and these things are kind of cool because this is using some of the newer .NET technologies like .NET 7. So we can create an ASP.NET Core minimal API. We can create a web API. We can just create an empty serverless app just as a starting point. We could do some .NET native AOT stuff on there, and then we can use containers. Like so, this felt like it was a lot more modern, I guess, compared to the other part of it. So that's why I wanted to bring this out to light, I suppose, or to talk about it. But what the team also didn't want to do is they didn't want to go too far away because we need to upgrade this project. And looking at all these different blueprints, this one here, the ASP.NET Core web app, seems to be similar enough. Even though it doesn't have a server, it's still going to create a web application with Razor pages, which is what the previous application was using. So that way we could still leverage all those Razor pages, and when we do our upgrade, maybe we'll just copy and paste them into this new app. We're still experimenting, so we don't know yet. But so that creates a new project over here, and it kind of gives you pretty much the same style of a ASP.NET web application that you would normally be used to, but it has some entry points that are a little different, and some other templates and things for AWS to be able to instrument it and deploy it. And it's sort of, I guess, what it ends up deploying is a CloudFormation stack that has an API gateway proxy with a Lambda function that has your code as the web app, and then that gets spun up in a container, and so then when you hit it, all those things magically come to life, and it's totally stateless at that point, which I thought was nice because that's usually what you want with a web application. And then if you did want to add state to it, you could put a DynamoDB or some other kind of a database on the other side. And so yeah, so you can run this app as normal. I mean, it's the same Visual Studio local development experience. Just I guess this is part of it was kind of interesting is there's this Lambda entry point. This is where the Lambda function is going to enter from the API gateway, and you can come in here and override stuff or set up some other things if you needed to. Just left it as the boilerplate. And then even better though is we need to. So we've developed on this for a minute, and we've got some pages out here, and we just wanted to, we wanted to get a demo out for our users so they could see what we've been doing. The cool thing is that even though that the other team's still working on how to get this thing deployed out there, because we had the problems with the web server, you can just actually right click on your project and publish it directly to AWS Lambda, which is kind of nice. And so we can come in here and create a new stack, and it's going to drop it into a S3 bucket, and then you can change the region and all that kind of stuff. But I just wanted to show kind of how fast it is. It's kind of impressive for me anyways. The fact that you can start with nothing and then have something published, and then it doesn't even have a server. It's kind of just blew my mind, I guess.
You'll be able to like go to that URL once it's done.
Yeah. So once it's done publishing it, should be done here pretty soon. Oh, actually, while we're waiting, I'm just going to bring up the other web application that it deployed, so you can kind of see that it actually did deploy something. Oh wait, go back here. Some codes. Okay, so yeah, from inside the CodeStar project, you can actually view the application that you had deployed to your EC2 instance. It's not running. I wonder if it got messed up when I might have broken it when I did those last builds. It must not have gotten deployed all the way. When I originally deployed it, though, it did actually have a running website, and it wasn't until our team broke it. So that's why we're developing the next version, I guess. So yeah, so this is the output from the sort of CloudFormation template that was just that I just kicked off, and it did deploy it, and here's the URL that it created for us, so we can go off and look at that. And hey, our old site doesn't work, but we got the new serverless one. We don't need servers anymore. It's another maintenance point, right? So yeah, and you can see it actually goes to, it has its own, I mean, it goes to other stuff too, but it's actually a website that you can use. That's kind of cool. In summary, yeah, so in a few parts, we talked about the DevOps history, the culture, practices, the theory of constraints, and the 3 ways. And then we looked at the Amazon's transformation from a single monolithic website to 150 million deployments a year. And then we reviewed some of the developer tools that you can use to make your life easier with the AWS cloud. And then I've got some links in here that it's just when we send out the slide decks, they're pretty much the same stuff that we already looked at through that. So I guess that was it then, unless anyone has questions.
I had a question. It was a little while ago. It was, if you go back, it was on one of your slides before the demo, but I don't, if you maybe go backwards through.
Sure.
It was, right, it was kind of toward one of the beginning slides. Sorry, I just, what is that one? Oh, sorry. Can you go back? Oh, can you? Okay. Go forward twice.
One more.
Yeah. Can you go into a little bit more on like the aligned incentives part? Like, what does that mean exactly?
Oh, right. Yeah, so that was where there were all these, so they had all these different teams, and they were all small teams, and they wanted to make sure all the teams were aligned with the same kind of common goals and things. And so that was where they gave them full ownership, so that they were totally autonomous and empowered, and and they were aligned, meaning that they, whatever they developed was also going to be deployed to production, and so they had to be the ones that that were like performing the work, I guess. And so I don't know if I'm explaining that right, but basically the organization aligned all those teams' incentives by giving them this accountability, and that way they all had the same sort of, they're all working towards the same goals, I guess.
And
If that
would it all?
same style, maybe.
Right, that makes sense.
Yeah, I don't know if I explained that right.
Would it also be like the people within the team? Because you said like maybe you have some developers, maybe some security people, maybe some project people or designers, like they all now have an aligned incentive because they're in the same team.
Right, and they all hear the same thing, and they all know what the same problems are, versus like I'm in one silo over here and you're in a different one, and I have no idea what you're even doing, maybe,
Right, gotcha. Okay.
I think that's sort of the idea, yeah. I'll explain that right. All right. Was there any questions from the people on the phone?
I didn't see anything.
Okay. All right.
Cool.
Thanks for coming.
Thanks, Reese.